Good morning. I'm Nick Kridler. I wrote this app calling Sirbarksalot, and it's doing some bark detection in Python. So I'm going to be talking to you about my dogs. And so this is Cody. He is a miniature dachshund. Well, he's more of a tweeny, medium-sized dachshund, and he barks a lot. And so I'm going to be telling you more about him in a little while. But first, let me talk about how he has a really good life. I mean, look how comfortable he is here. He likes chewing. We give him these sweet potatoes or yams on blankets for some odd reason, and lots of other things. This is his favorite ball, but he doesn't like the gardener. He doesn't like fireworks, other dogs, people at the door. These are lots of things that set him off. And by the way, there's also my other dog, Kaylee, and she also has a pretty sweet life. And so despite their comfortable lifestyle, he still barks a lot. And we've even tried to come up with ways to mitigate this. And so we've gotten him these fashionable earmuffs, but they don't seem to do the trick. And so I was sort of curious, how much do they bark when we're at work? We know they bark a lot when we're at home, but are they causing the neighbors a lot of trouble with their barking? And so in this talk, I'm going to first tell you a little bit about myself and why I would build such a thing, and then the components of this, so the audio capture, bark detection, and then I made a little Facebook Messenger component, and then some analysis that I did. So real quick before I jump into me, what is Sirbarksalot? And so basically what happens is one of the dogs will bark, so Cody or Kaylee barks, and I have this old webcam that I've set up with my computer, and it creates a spectrogram and then tries to determine if there's a bark, and if there is, it sends me a message on Facebook, and it tries to, I think, count up over every minute or so, tell me how many times that they barked. And so, as you can see, I get a lot of messages. And so first, a little bit about me and why I would know how to build such a thing. I'm a data scientist at Stitch Fix. I got into data science through Kaggle. I did some competitions around whale detection, and so some of the techniques are techniques that I used in the whale competition. Like I said before, my dogs are Cody and Kaylee, and I'm mildly addicted to Final Fantasy. When I'm not working on Python or work-related things, I like to play Final Fantasy 14. So what do I do at Stitch Fix? For those of you that don't know about Stitch Fix, we are a fashion and personalization company. So you sign up on the website, fill out a profile about yourself, about what your size is, what you like to wear, what are your different style preferences. And we have stylists that go in and look at recommendations that our team has generated and pick out 5 items for you. And then we send it to your house, you try it on, keep what you like, and send back the rest. And so I work on the merch algorithms team, specifically on vendor data and algorithms. So our vendors, say it's like Kate Spade or Theory, I provide them with data that tells them about how they're doing. And then I'm also working on how do we characterize vendors more broadly, how do we cohort them, and then eventually provide recommendations about which vendors we should work with. I have also worked on inventory quality, so trying to come up with measures of, is our inventory healthy? I provide recommendations to our planning team about how many styles we should carry, and do some forecasting on health. But overall, I build data products mostly in Python. Right? And other people at Stitch Fix do a lot of really cool things, and so some of these, you see a lot of interesting pieces that people are working on. It's like, oh, I'd like to learn that. So I try to find a reason to learn some of these new technologies. And so there's actually this great algorithms tour of everything that we do at Stitch Fix. It goes through the recommendations and how we do inventory planning and warehousing, all this stuff. It's really awesome. I highly recommend taking a look. And there's some things that aren't listed in the tour. There's some work done with neural nets, this open source package called Photograph. I have a web app sort of helping package called Pixely, and then there's this app, this Facebook Messenger app that people are working on called Style Shuffle that allows people to rate items in our inventory. But generally, we build a lot of really interesting things, and so it's sort of inspiring and definitely motivates me to like learn something new and build something new. So why Sirbarksalot? Well, why not? I primarily wanted to learn TensorFlow just because the type of work that I do day to day doesn't really have a like need for deep learning or machine super sophisticated machine learning. I can get away with a lot of like really simple things, and I wanted to know how much my dogs bark, and so this was the motivation. Okay, so now I'm going to talk about how to actually build this thing, what I actually did. And so the first step is audio capture. So the idea is that when the dogs bark, I have this old webcam, and then it's constantly listening. So it's listening for any bark, and then if it hears something, that's what we're looking for. And so I found this library called PyAudio, which wraps the port audio. And I'm using Ubuntu at home, so it's kind of tricky to install just because I happen to have like an old webcam that was not well supported by anything. But it's really simple. You just start a stream. You pass it this like config dict, and you start a stream, and then you can easily record. So you just like, if you want to record a certain number of frames, you just loop over and then build a list, and then you can those are all bytes, and so you can turn that into a NumPy array. And so this thread like executes roughly like every six seconds and makes a recording. So then the next step is bark detection. So I've got these audio clips. How do I decide if the dog is actually barking? And so what I do is create these things called spectrograms, and I'll talk about that in next slide. So a spectrogram is a time frequency like power plot. So the color is power, and then the y-axis is frequency, and then the x-axis is time. And so these regions that I've circled here, those are all barks, right? And so in this particular case, one of the dogs barked 4 times or something. And so so what I was hoping to do is turn this into an image classification problem where these are the things in the images that I'm looking for. It's also interesting to note that making a spectrogram can be done in Matplotlib using the MLab module. And so, you might wonder, are all barks the same? Well, Cody and Kaylee actually have very distinct barks. I didn't take advantage of that yet, but you can see that Cody has sort of a deep bark that shows up at lower frequencies, whereas Kaylee has a much higher pitch to her bark, and it shows up at higher frequencies. Okay, and so the first step, my V0 detector, was similar to what I used in the whale competition, which is template matching. And so the idea is if I cut out a region of the image and I say this is my template, what I'm looking for is a correlation with if I was to slide this template across the image, the correlation at every point. And so if I do that, then I get a plot that looks like this, where at every time unit I get a correlation value, and basically just draw a line at 0.75 and say anything greater than that I'm going to call a bark. And this actually works reasonably well. Right? And so that's the V0 version. And so I mostly use this for data collection because one, so I would have this running, determine the max cross correlation. If the cross correlation was greater than 0.75, I save that file, and then now I'm building this like set of data that I can go in and label. And most of the times they were barks. There's some few false alarm sources, and I'll talk about those later. But yeah, for the most part, there was very few false alarms. It limited the amount of labeling that I needed to do because I was pretty confident. But it biases the training data because everything is collected under this assumption that it's greater than 0.75. And it's only with one template. And so if there are barks that look sort of different or don't pass the threshold, then I'm not collecting those things. And so what I also do is just sort of flip it, and anything less than 0.75, record for a little while, collect a manageable amount of samples, and then go through that as well. But barks are for the most part, greater than 0.75. So this works reasonably well. And so I used this to build a data set so that way I could get started with TensorFlow and Keras. Keras has a really nice API that makes building and training a model like super simple. It's kind of crazy how simple it is. So the painful part was actually just installing everything. So I have Ubuntu and I have an NVIDIA graphics card. I followed the installation, and that part wasn't that bad, but CUDA on my particular machine, I'm not sure if it was drivers or whatever, but that was particularly tricky. I think in the future I'll probably just like set up a Docker container or something that's just fixed. And then I really stuck with simple models. I trained a convolutional neural net, and I followed the Keras documentation and examples. And so I really just went through their examples about how to build a binary classifier. I didn't do any real parameter tuning because my goal was not to have the super precise classifier, but rather to have a different way to collect samples. And so I wanted to like still collect barks, but I wanted to collect things that were sort of similar to barks that I wasn't catching before, just to diversify the training set. And so then the last component of this whole thing is this like messenger app. And so this part is actually really easy. Once I've found a bark, I just want to send myself a message on Facebook. To let me know that they're barking. So this is great for when I go out of town because we have a pet sitter that comes by and watches the dogs for us when we're out of town. And so I get basically alerts when the pet sitter shows up. I get to see that my dogs are barking at 1 in the morning and the pet sitter doesn't get to sleep. So, but it's, it's pretty useful. So basically, like I said, I just wanted to know when they're barking, but I don't want to be flooded with messages. So I followed the Facebook tutorial. It's actually really simple. You create a page. So in this case, I created a page for Cody and Kaylee. You create an app in the developer portal, and all you have to do is link the page that you created with your app. They give you a token, and then the token can be used to hit their Messenger API. And so it's not really a bot because it's just one-way messaging, right? So they send me messages when they bark, but if I send them a message, nothing happens, right? And so I didn't deploy anything, so there's no this is just running on my home computer, and it's just hitting the API. There's no like instance fees or anything like that. And like I said, it's really basic. I have a function that sends me a message. It has some correlation score, the number of barks that occurred in some time window, and basically I've just created a URL that has a token in it, and it just does a post with the JSON. Right. And so now I'm going to talk a little bit about digging into the data and so what have I learned from all of this. And so some fun facts. I've labeled just over 2,000 6-second clips. Cody's barked 848 times. Kaylee's barked 566 times. And so the interesting thing is we always thought that she would be like this like great apartment dog. She doesn't bark that much when we're at home. But it turns out she does her fair share of barking as well. So Cody barks at anyone at the door, other dogs barking, or just complete silence. So if he hears nothing, it's time to bark. Kaylee barks whenever we come home. She's super excited. That's how she expresses her excitement. Or if she has put her ball in a place that she can't get to, she needs to notify us that we should get it for her. So I made some just simple like histograms of when they bark based on the hour of the day. In Pacific time, because it's my time zone. And what's really interesting is they don't really get going until about like 10 a.m. So they sleep in a little bit. Cody definitely barks more, and it's kind of interesting how they're sort of shifted around like Cody barks a little bit later in the night, and Kaylee a little bit sort of like early afternoon. So what I've done is, weekdays we're at home, weekdays are at work, weekends we're at home. So I've only looked at the weekdays, And first thing that is, we get home around 5 o'clock or so, and they seem to do most of their barking when we're at home. So that's unfortunate. Cody in particular really likes to bark at night. Kaylee appears to sleep in till like 10. So yeah, she's pretty quiet, but then at 10 she barks just as much as he does. And there's a little bit of an overlap with the two of them, because if she barks, he will start barking as well. So they typically bark together. And then if you look just the weekend, it's kind of interesting that, like, let's see if we go back. So there's this like sort of bimodal distribution. On the weekdays, it's just got one hump. The weekend is the other hump, and that's when our neighbor's gardener shows up. And so that's when the barking happens. Cody really hates the gardener. It's like the leaf blower or something like that. I don't know. And then, so like, just to get a sense of like on the average day, how does it look? And like during the daytime, maybe like 1 to 2 or 2 to 3 barks per hour, but then when we get home, it's like more like 6, and he like really ramps it up. And so I wonder if it's like he's protecting us or something. It's kind of interesting. And so the last thing I'm going to show are just some false alarms, some things that the detector picked up that are not barks, but makes sense when you understand how I'm doing all of this. And so remember, I'm doing this template matching, and so I have this template, and the top one is a cough, and so you can see the cough actually looks pretty similar in the spectrogram space. We have a dog gate that closes, and when it closes, it just seems to light up all the frequencies, and so that also, and then the amount of time that it takes also is pretty similar. And then laughing also I guess is a really loud laugh. So these were pretty interesting, but it shows sort of, these are typically things that don't have to worry about when the dogs are not home, which is why the detector works so well during the day. And then the convolutional neural net that I trained, because I didn't really do anything fancy, I just sort of let it loose and did a simple thing. It picked up on some music, which is kind of interesting, and I wonder if it's just like sort of the time between like the peaks. Again, the cough shows up, but it that sort of not unexpected. And then music, and I wonder, so this is the same kind of thing. I think it was like bass or something. And so if you remember one of the pictures I showed of Kaylee barking, like she had this like pretty evenly spaced bark in time, and I wonder if it's picking up on that sort of thing. So these are sort of interesting and sort of a way I can sort of diagnose like how to maybe improve the model. And so the future, I'm going to do more data collection, work on actually try to turn it into a multi-class classification. Is it Cody or is it Kaylee? Try to improve the accuracy and play around with different parameter space. Maybe create a dashboard to track their barking, just something that, like maybe it's just like a simple app that just sends me like, you know, this is one of them barking, or this is a clip, is it a bark, yes or no? And so that's all I have. The only thing I wanted to add is it's kind of amazing how you can basically just follow a lot of these different like getting started tutorials and go from having like a bunch of different things to like, you know, a pretty decent working app. So thanks.
All right, thank you, Nicholas. I failed to mention it at the start, but as with yesterday, we're taking questions tweeted in at PyData Seattle. We don't have any yet, so at this point I am going to throw it open to the room. If you have a question for Nick, feel free to ask it, and I'll repeat it so everyone on the stream gets it as well. Does anyone have? Yes?
Do your dogs always bark in the same room? Does it matter where the webcam is?
Oh, it doesn't matter where in the house the dogs are barking.
It turns out it doesn't matter where it picks up just about any room in the house. And so they bark loud enough that if they're in the back bedroom, I have it by my computer, which is in the other side of the house, and you can still hear it.
Is this something that could potentially become like an Echo app or something where maybe one of the big companies is going to, you know, acquire you?
You know, I thought about that. I think that would. I haven't played with the Echo API yet, but it seems like a different or a interesting way to take it.
You're going to have something constantly listening in your house. It may as well be passing on useful information about what other people are barking.
Yeah.
Another question there?
Yes.
I was also say the same thing. You should totally do an Alexa scale.
Okay.
But my question is, I know you said two dogs bark very differently.
Mm-hmm.
So how do you really identify which bark belongs to which dog, just based on the data?
So listening. If you want, I can play a sample
Yeah,
of
please,
them
please
barking.
play some samples. The question was, how do you actually tell the difference between the two dogs? Is it simply based solely on the spectrogram? How different do they sound? And hopefully we can get some samples. I hope the audio is going to work.
So I warn you. Let's see. I think if I. Oh, of course it's going to open up this stuff. Waiting for Bluetooth device. Never mind that. Is there a different way I could? Will QuickTime play it? There we go. So I don't know if you can tell. Could you hear
Is that a gardener bark?
That's just, they're both like sort of excited. So I don't know if you could tell, but they were both barking, and one has a high. So let's see. So Kaylee has the really high pitched bark.
And so that's going to show up on the spectrograms you had earlier as
It's a
different.
higher pitch. Yeah,
the
the high
higher pitch.
frequency. Yeah.
So
And then Cody's is.
Window walls that lead out to the accessory deck. Can you imagine Hawaii?
That's at the end. So I think my wife was watching Fixer Upper or something like that.
So that leads nicely into the next question. Do you have you been able to use this to get a better, obviously you showed the histograms to show when the dogs are barking. Has it led to a better understanding of why they bark, what causes them?
Yeah, because I labeled all the clips, you can hear other dogs barking, you can hear just like knocks at the door, like if we have a package delivered or something like that. And so a lot of it is alerts, like the dog has heard something that he's trying to alert us about, I guess.
What potential do you think something like this has for training dogs either not to bark or to bark at certain times?
Oh, I'm not quite sure. I mean,
we're just exploring this if anyone is looking for an acquisition.
Yeah, well, so one thing that I was thinking that I could do is, so we have a radio that plays during the day to try to mitigate their barking, right? To try to keep them from hearing things that happen outside. And so I was thinking I could test different playlists and see how it affects their barking.
Dynamically adjust it.
Yeah.
It's like when they start barking more, it's like switch the playlist
Right.
up. Go from the heavy metal into smooth jazz and try and calm them down a bit.
Exactly.
If you haven't heard from them for a while, then start playing gardener noises and go, oh, they are still there. Excellent.
Yeah.
Excellent. Any other questions from the room? Yes.
I'm curious how much audio data.
How much audio data have you collected?
I think it's just a couple gigs at this point. It's not that much. It's, like I said, it's like just over 2,000 6-second clips, and it's single channel, so they're pretty small.
So yes, it will fit on your iPod. You can take it home and listen to it all. Anything else from the room? Yes.
It's more of a suggestion, but have you heard of the Python package Aubio, A-U-B-I-O?
No, I haven't.
So Python package Orbio. Please continue.
You could probably get more features. Like they do more than just onset detection, which I think was the main feature that you're using here. Like I use it for like music projects, so you can do like pitch detection and a couple other features which may help with accuracy.
Oh, great. Thank you.
Yeah, so for the people that didn't hear that, there are other packages out there. Orbio was the one that was suggested just then. This was using onset detection. Essentially, when the sound starts, we go, oh, there's a sound, let's analyze that from there. But there are alternative ways of doing audio analysis that other libraries are going to help with that may give better results or different results depending on the sort of audio you're dealing with. So, is there anything else from the room, or are we going to take a break? That looks like it might be it. Do you have anything else you want to?
Yeah, if you want to talk to me, just come find me, or if you want to learn about Stitch Fix, you can come find me as well. Cool.
Great. Thank you very much, Nicholas.